Hello, Math 10C. So we are on to chapter 2, which is all about trigonometry. Now, in this trigonometry section, we are pretty much always going to be trying to look for what's called a right triangle. Okay, we've been introduced to right triangles. Remember, a right triangle is something with a 90-degree angle. Okay, has a 90-degree angle, and then you may remember the names of these legs, but we'll go over that in a little bit. But it's mainly to do with the 90-degree angle. Now, 2.1, we want to focus on the tangent ratio first. Okay, so what we're going to be introduced to is a new way to remember all these different equations. Okay, it's called SOHCAHTOA. So you kind of want to write this on your forehead and try and remember what SOHCAHTOA is. Okay, it's a memorization tool. It tells us these ratios. Okay, so for sine, okay, what we're going to be introduced in sine is this represents sine. Okay, this is opposite, and this is hypotenuse. Okay, for cos, this is adjacent, and this is hypotenuse. And then finally tan, this is opposite, and this is adjacent. So how do I write that into formulas here? So if we look here for SOHCAHTOA, this simply means sine equals opposite over hypotenuse. Okay, so you always read the first word, that equals opposite over hypotenuse. Okay, so sine equals opposite over hypotenuse. Okay, now let's look at cos. What do you think cos would be? Well, it's cos angle equals adjacent over hypotenuse. Okay, so cos equals adjacent over hypotenuse. Okay, and then hopefully you can figure out what tan is based on what we did in sine and cos. Tan here, tan angle equals opposite over adjacent. Okay, so tan equals opposite over adjacent. Okay, now we are going to focus today on tan. Chapter 2, you do have to know how to use all of these things, but we're just going to mainly focus on tan. Okay, now let's label this triangle. Okay, let's try and remember how to label this triangle. Let's say, as we can see, this is a right triangle. Okay, recall what a right triangle is. A right triangle is something with a 90-degree angle. Okay, as soon as your triangle has 90 degrees, you are dealing with a right triangle. Okay, now let's label this. What does it mean by label? You always want to label your triangles in order for us to know, or the marker, or even just yourself to know what you're talking about. Okay, it's all about being descriptive in mathematics. So I'm going to label this triangle A, B, C, all in capital letters. Okay, now usually, let's talk about labeling a little bit. When you label a triangle, your points, okay, that are called vertexes. So I'm going to highlight the vertexes. This is a vertex. This is a vertex. This is a vertex. Or these points, okay, those are known as, you usually want to label them with capital letters. Okay, so label your vertexes with capital letters. And remember, a vertex you can kind of think of as just simply the points of the triangle. Okay. So that's usually how you want to represent this triangle. So now we could name this triangle. If we wanted to name this triangle would be triangle ABC. Okay. A, B, C. So it goes from A, it goes down to B, B to C, and then C back to A. Okay, so you could name that triangle nice and easy, and we're going to see that in examples moving forward. Now, how could we name the legs? So the legs are these two guys. Okay, legs are the ones that are touching the 90-degree angle. Well, normally what you do is you simply label each leg the lowercase letter from the opposite vertex. So notice how this is capital A. The opposite leg is line CB. So we could label this A, lowercase a. Okay? So that means if we look at C, what would be lowercase c? Well, it would be this line here. Okay, lowercase c would be this line because it's opposite from capital C. So this is lowercase c, okay? And now finally, hopefully you would know what to represent lowercase b with, okay? It would be opposite to this angle here, B. So this would be lowercase b. So now we've labeled our triangle real nicely, okay? Now, something to note. The side length that is always opposite of a 90-degree angle, okay? So this 90-degree angle here, now highlighted in brown, the side opposite of that is always known as the hypotenuse. So C is always going to be the hypotenuse. Sometimes it might not always be represented as C, okay? But anytime you are the side length opposite of the 90-degree angle, you are known as the hypotenuse, okay? So that is naming this triangle. So let's look at this. How would you name this triangle? Well, we just talked about it. I would probably name it as triangle ABC. Triangle ABC. Another way, recognize, just as long as you write it all out properly, this could also be just triangle ACB, right? ACB makes sense as well. Something to note is usually when you're dealing with a right triangle, you want that middle vertex to have the one with the 90-degree angle. So I would probably actually rather go with this naming format, okay? It's not something that you always have to do, but if you know it's a 90-degree angle, it's usually useful to put that middle one as the 90-degree angle, okay? Now, there's also a few things here. How would you represent the angle A? Okay, well, I would represent my angle A. Let's find angle A first. Angle A is this angle here. Let's maybe represent it in green. Angle A is this angle here. Okay, so we could represent it like this, angle A. So there's a few ways. We could say angle A, or, okay, another way you can represent it is this. This little value here means angle. And now we can easily find where angle A is. Okay. Now, let's maybe draw a triangle down here and talk about the tan ratio. Okay, so I want you to make sure you're writing all of this in your notes, right? So this is your tan angle. Now, when you're dealing with SOHCAHTOA up here, okay, you have to understand that your you're looking at it from different angles perspectives. So you have to imagine you're either angle A, or this one we could say is angle B. Okay, so if we look here, let's talk about this triangle in terms of tan. So, sorry, actually we're gonna go up here. So let's talk about it in the perspective of angle A. So angle A perspective. So if we look at from angle A's perspective, let's talk about that. So remember, let's remind ourselves what the tan ratio is. If we go up here, tan equals opposite over opposite over adjacent. It's TOA. So tan angle equals opposite over adjacent. Now, what does adjacent mean? A little side note. Adjacent simply means beside. Okay, so the thing beside you. Okay, so let's talk about it from tan angle A. Okay, so tan angle A. Let's look at angle A. So right now we are focusing on our green angle A here. Now, what is the opposite leg to angle A? Well, if you notice, the opposite leg to angle A is little a. Okay? So from angle A's perspective, little a is opposite. Okay? So if we write here, this is our opposite leg would be little a. Okay? Now what would be adjacent? So remember, adjacent simply means beside. So what's the leg beside angle A? Okay? You might be noticing that there is two options. Okay? You could say that little c is beside angle A, or you could say little b is beside angle A. Something really important to note. The hypotenuse here can only be the hypotenuse. It can never be adjacent. So as soon as you find your hypotenuse, I cannot be adjacent. Okay, and that's written at the bottom of your page. The hypotenuse is never allowed to be adjacent. So that means for angle A, the adjacent leg, or the leg beside angle A, would be little b. I'm going to show you how to represent this in different notation, okay? If you look here, leg A, okay, could also be represented as C to B. And that should be hopefully kind of obvious, because if you look here, this is C to B, okay? So we could also represent this as tan angle A equals C to B over, and what was B? B would be C to A. C to A. C to A. Okay? So that's an angle A's perspective. Now this whole ratio is going to change based on if we are looking at it from angles B perspective. Okay, so let's talk about angle B's perspective. Okay, so angle B here is going to have a totally different setup. So let's look at angle B. Okay, so for tan angle B, remember, tan is still opposite over adjacent. It's just that the opposite side is going to be different this time. If we look at it from angles B's perspective, what's the opposite side length? Well, the opposite side length is our B value. Okay, and I'm just going to get rid of that. So opposite will be B on top. What's the adjacent side? Remember, you have two options for it to be adjacent, but recall that hypotenuse can never be adjacent. So that automatically makes A the leg beside, so adjacent to angle B. So let's put that down as A. And again, we could represent this using a bit of a different notation, okay? And each notation is just fine. So leg A to C, okay, is our leg B. So we could represent this as A to C, and then our leg C to B is leg A. So this would be C to B. So there is our tan ratios. Okay, this is known as our tan ratio for angle A. This would be our tan ratio for angle B. Okay, so there's a lot of writing going on here, which is okay. But remember, important things to do. Label your vertexes, okay? Always find hypotenuse right away. Hypotenuse. Okay, so find your hypotenuse right away. And remember, it's the leg across from the 90 degrees. Okay, so here's a few things on the bottom here that you really want to remember. The hypotenuse is always opposite of the right angle. So we just talked about that, right? Your hypotenuse is always opposite of the right angle. So this guy here. Okay. And then SOHCAHTOA only works for right angle triangles. So right angle triangles is as soon as you have that 90-degree angle. Okay. So if any of this confused you before we move forward, you got to rewatch it again. Because in order to do these questions, you need to understand what we're talking about. So let's see a few examples here. Okay. So draw the triangle GFD and label the sides. How do the side lengths relate in terms of Pythagoras and the tan ratio? So at the moment, I should have actually written here in the question, draw a right triangle GFD. Okay, because we're talking about right triangles. If it doesn't say right triangle, you don't have to assume it's a right triangle, but I should have put right triangle there. So sorry about that. So draw a right triangle that is triangle GFD. Now, notice it doesn't tell us which angle to make that 90-degree angle. So that means I'm going to make this middle one my 90-degree angle. Okay, so this will be my 90-degree angle. So if I draw this, I need my lines G to F and F to D. So I'm going to make this point G, and I'm going to go down, make it as straight as I can. And then I'm going to make a 90-degree angle. So G to F, and then F to D, and then I'm going to connect the two. So notice I made my F, that middle letter, my 90-degree angle. And now I have my right triangle. Okay, and then if we now consider labeling our side lengths, okay, F to D can be represented as lowercase g, okay? So F to D I could put as G, okay? You could either use little g or you could represent it as F to D. It doesn't really matter to me, okay? But you have to know both notations based on the certain types of questions here, okay? G to F could be represented as lowercase d, okay? Because it's across from D. So this would be lowercase d. Or GF, okay? Maybe let's put this like this, G to F. Okay, and then finally, hopefully you know what to label G to D. It would be lowercase f, because that's what it is across from. So this will be lowercase f, or you could represent it as G to D. Now, anytime you're faced with a right triangle, you want to find the hypotenuse immediately. Remember, the hypotenuse is across from the 90-degree angle. So this means G to D will be my hypotenuse. So I'm just going to represent that as HYP, because you probably noticed I've spelt it wrong a few times. So let's just represent it as hypotenuse, okay? We can't name opposites or adjacents quite yet because we haven't focused on any values. and we're not focusing on the perspective of an angle. Okay, so let's do this. So we've done the first section. Let's do this next section. How do the side lengths relate to the terms Pythagoras and the tan ratio? Okay, so let's talk about Pythagoras here. Pythagoras. Okay, so if we talk about Pythagoras, remember Pythagoras is a squared plus b squared equals c squared. The most important thing in this equation is that you understand c squared is known as your hypotenuse, always. Okay, so if we relate it using these triangles notations, we automatically know that c is the hypotenuse in this equation. In this case, c is f. Okay, so I'm going to represent this as f squared because it has to be the hypotenuse. Now, a and b are interchangeable. I could make g a, or I could make g b. Okay, all that really matters is that you made c your hypotenuse, and you make sure that that's the same. The legs are interchangeable. Okay, so I could write this as I can make a d, so I could make a d. So d squared plus, and I could decide that I'm going to make b g squared. Remember, the non-hypotenuse are called legs. Legs are interchangeable in Pythagoras. Okay? So that is the equation for that. Now, so we could use this equation, obviously. Hopefully you remember how to use Pythagoras. You'll see a few times where we use it today. And then go from there. Remember, the big important thing is you know where to put your hypotenuse in this equation. Now, how can we relate these things in terms of the tan ratio? Okay, remember, in order to use any of those ratios, you need to focus on an angle. So let's talk about it using angle D. Okay, so angle D here, and maybe I'll change my pen for this section, just so it's a little easier to see what we're talking about. I'm going to write this again and put angle D. Okay, so angle D is found right here. Okay, again, we could represent this as angle D. Now, let's remind ourselves what the tan ratio is. Tan angle, and remember it's TOA, so TOA, tan angle equals opposite over adjacent. Tan angle equals opposite over adjacent. Okay, so where is our opposite side to tan? Our opposite side to tan is found, let's look at it. Okay, let's see. If we are in tan's perspective here, the opposite leg would be D. Okay, I'm going to get rid of that. So it would be D. So that means if I write tan angle D, you always want to use these little subscripts. The opposite side is D. Okay, so I'm going to write D up here. Now, what would be the adjacent? Okay, remember, you kind of have two options. The things beside D, angle D, are G or F. But remember, our hypotenuse can never be adjacent. Okay, so that means we are left with G being beside angle D. So that means the adjacent side has to be G. Okay, and then that is our ratio for tan angle D. That's how to relate these three things. Okay, remember, we could represent this, and it's good practice too, in terms of different notations. So side length D is also represented as GF. So we could put it as GF over FD. Okay, so there's two different ways to represent our tan in terms of angle D. Okay, now let's do it again, but focus on it as if it's angle G. Okay, so in terms of angle G here, remember, let's remind ourselves just the simple generic formula, tan angle equals opposite over adjacent. Let's find it in terms of angle G. If we look at angle G here, what's the opposite leg? the opposite leg for angle G would be G, okay? G or FD, let's put it as G. What would be the adjacent side? Remember, we do technically have two options here, okay? You have this option or this option. What are the beside lengths? But remember, this won't count because hypotenuse can never be adjacent, okay? So we are gonna go with D as beside. Oops. So let's write that down. The adjacent is side length D. And there you have it. Again, let's represent it in a bit of a different notation. Okay, so tan angle G, we could also represent as FD. So side length G is also known as FD. And then side length D is the side length G to F. So we could represent it as G to F. Okay, and there's two different ways to represent tan angle G. Now, we've related all of these sides now, which is super nice, okay? So if any of that confused you, please come in and ask questions. Remember that since this told us it was a right triangle, we were forced to make that middle letter a 90 degree, unless the question tells us otherwise, okay? But if it doesn't tell us which angle specifically is the right angle, you assume it's the middle one. Now, let's kind of pull up our calculator here. Okay. And remind ourselves where to find tan. So if I clear all this, tan, okay, as we can see, I'm going to be pressing it here, and hopefully you see it blinking. Tan is found right there, okay? Now, you also need to know how to use inverse tan, okay? So if we find inverse tan and plug in the ratio, you can actually find the angle. How do I get to inverse tan? So your calculator is going to look a little different, but kind of the same, okay? And things to note about this calculator, okay? Do you see all the yellow little letters? So like right where it says tan, okay, hopefully you see in yellow letters, you see tan -1. That's known as inverse tan. So if we plug it, if we want to get to the yellow letters, you want to press the yellow button. Hopefully you can see me pressing the yellow button here, okay? And when you press that yellow button, now anytime you press one of these buttons, you are actually using the yellow values. So if I press second, so right now second, that yellow button is activated, and I press 10, it'll pop up tan -1. And if I plug in a ratio here, so let's do 2/3. Oh, so tan 2/3. It's going to give me, this is actually degrees. So that's a 33.6 degree ratio, or sorry, angle, okay? So inverse tan finds the actual angle. So it can be confusing trying to understand when to use tan inverse and tan, okay? For tan, this is when you're trying to find, if you're given an angle and you want to know the ratio. So if you are given an angle, okay, an angle, and you want to find the tan ratio. And remember, the equation's kind of a giveaway. Tan angle equals opposite over adjacent, okay? So if we have the angle that we're kind of focusing on, if you just plug tan 32 in, okay, it'll pop up the ratio here. Now, inverse tan, just understand that inverse tan finds angles, okay? So this means your angle equals tan inverse opposite over adjacent. So we actually plug in our ratio and it'll pop up the angle that we're talking about. So if we go up here, if we wanted to find out what angle D is and we had GF and FD, we would plug in angle D equals the inverse of D over G. And remember, D over G is what the ratio is here. So if we actually wanted to figure out what angle D is, you would plug this in to find that angle. And we'll see us using that. Now here's a few instructions on how to use and find it, okay? Using tan is really easy. You just have to understand anytime you press just normal tan, the angle has to be inside. Anytime you press tan inverse, your ratio has to be inside. This can be kind of hard to understand. Please come in if that didn't make sense, but seeing an example might help a little bit. So let's see an example and then move from there. So guys, this is gonna definitely be the longest video of the section. So don't feel like all of it's gonna be, it's because we're introducing you to a lot of new things. Now, determine the ratio of angle F, okay? So right now we just want the ratio. We want the tan ratio. We don't want the angle. All we're looking for is what does tan angle F equal, okay? You don't have to find the angle in this case. This is just talking about the ratio. So in order to use tan angle F, remember, we're gonna do opposite over adjacent, TOA. Okay, so let's look at angle F here. So angle F, if we see that opposite to that is 10. Now, this is something really important. Recognize that this is your hypotenuse, okay? It's across from the 90-degree angle, okay? So that means you don't want to jump the gun too quick. I already know that lots of people would immediately put this as adjacent. But remember, hypotenuse cannot be adjacent. So that means this guy is going to be adjacent. That means we have to find E to F. So in terms of angle F, this is opposite, this is adjacent. We need to find that adjacent. So what I'm gonna do is I'm gonna label these a little bit easier, okay? I'm gonna label D to F as just simply D to F. So I'm gonna put this as D to F. I'm gonna label E to F, obviously E to F. Again, we could label it as the lowercase d because it's across from capital D, but let's just do it this way. And then our leg D to E, I'm just gonna represent it as D to E. Now, for our ratio here, our equation, we only have the opposite leg. How the heck are we gonna find the adjacent? Well, that's where Pythagoras comes in. So remember, let's find E to F. Okay, so recall, a squared plus b squared equals c squared. The main important thing is that your hypotenuse is where C is. Okay, so I'm gonna immediately put C down for D to F. So this will be df squared, okay? And then remember, your legs are interchangeable. It doesn't matter as long as you put the hypotenuse in the proper place. So this will be D to E squared plus E to F squared. And now let's plug in our numbers. So if we plug in our numbers, D to E we see is 10. Okay, so I'm gonna plug that in. This will be 10 squared plus, we're trying to find E to F. And then D to F, which is our hypotenuse, is 17. So this is 17 squared. Let's plug these in. So if we actually plug in 10 squared, so how do you do that? You're gonna press 10, and then you should have a little square button on the left side of your calculator. In this case, we can see it found here, okay? So I'm gonna press squared. That gives me 100 plus E to F squared. And then 17, remember, 17 squared gives me 289. And now I'm going to solve for e to f. So I'm going to subtract 100. I'm going to subtract 100, and I'm going to get e to f squared equals 189. Okay? So now we have 189, and we're not done. Remember, this thing is being squared. So in order to find what actually e to f is, we got to square root. Okay? So that means e to f is going to equal. Now, how do I get to square root? Well, if you look here on square, okay, if you look on the squared button, right above it, or on the same button in the yellow, you can see a little square root symbol. This is going to be roughly in the same area of your calculator. Since it's yellow, I'm going to press second, or the yellow button, and press that. Now I have my square. And I'm going to plug in 189. Okay, and that's going to give me 13.7477. I'm going to round it to about 4 decimal places. 13.7477. So there is my length. And we're measured, doesn't give us a measurement, so that's okay. So now we have e to f. E to f equals 13.7477. Now, we can figure out our tan ratio. So if we look here, we can rewrite tan angle f. What's the opposite leg? Well, look at angle f. Opposite is d to e. Adjacent, it cannot be hypotenuse, so it's going to be 13.7477. Oh, sorry. Right now we're just labeling it, so it'll be e to f. And now we can plug this into our calculator. So it'll be 10, which is d to e, over 13.7477. Okay? We could maybe leave it as that. Sometimes it'll ask us to round it to the nearest decimal. So we could just plug that in to our calculator if we really wanted to. So let's do that. 10 divided by 13.7477. And that'll give me 0.727. So let's round it to the nearest hundredth. So 0.2727. There's no units on this thing. Okay, and that would be your answer. So the tan ratio for f, tan angle f, simply equals 0.727. Okay, and that's the tan ratio. We don't have to do anything else. Now, that's a little different for B. It wants us to actually determine the angle of f. Now remember, in order to determine the angle of f, you have to use inverse tan. So angle f is going to equal tan inverse, okay, inverse tan opposite over adjacent. Okay, anytime you're trying to find the angle, you have to use inverse. So in this case, angle f will be opposite, which we talked about is 10. Okay, remember the opposite length from angle f is 10. So it'll be 10 over 13.7477. Okay, and that's going to be, how do we plug that into our calculator? Well, let's do it. So remember, we want to use inverse tan. To get to inverse tan, we need to use the yellow button, and now we press tan. It brings up that, and I can just plug in 10 divided by 13.7477, and it gives us 36, and I'm going to round it to the nearest degree. So this will be 36 degrees. So now we have found the angle of angle F, which is great. Okay. Now, the things to recognize here is we could have also just simply plugged in this decimal, because this decimal number is the tan ratio. It is 10 divided by 13.7477. So if we wanted to do tan inverse 0.727, 0.27. It'll be like a few decimals off because we've rounded, but it's pretty much roughly the same. Okay, that's why you want to take a few decimal places every time before you get to your final answer. Okay, so there's still a few more examples in this video, but that was a lot to go over. So this is going to be the first part of chapter 2.1, and please go to part 2 when you're ready to watch the remainder.